This is the first chapter from Express JUnit. Hi, my name is Jim White. So exactly what is JUnit and where did it come from? Well, back in 1997, Eric Gamma and Kent Beck created JUnit. It comes from some of their original work in SUnit, that is, unit testing for Smalltalk applications. If the names Gamma and Beck sound familiar to you, that's because they're pretty famous guys in our software industry. Eric Gamma came from the Gang of Four design patterns. Kent Beck's fame stems from his work in extreme programming. So JUnit, in their own words, is meant to be a framework that provides simple but effective unit testing. It is an open source software library, meaning it's free. You can use it today in any work you work with. Per JUnit in Action, the text that we're actually following for this course, you'll note that there are 3 rules all unit test frameworks should follow. Unit test frameworks should offer unit tests that run independently. They should detect and report errors test by test, and it should be easy to define which tests to run. All characteristics we see expressed in JUnit today. Additionally, our text suggests the framework should help us write useful tests, help create tests that retain their value over time, and help us lower the cost of writing tests by reusing code. Again, all characteristics which we hope to see through JUnit here today. Now, how do you get JUnit? Well, you go out to www.junit.org. The latest version, as of this recording, is version 4.9. That will provide you with the JUnit jar file, and that jar file has to be on your class path. When inside of an IDE like Eclipse, that means adding the JUnit jar to your Eclipse class path, or what is more often referred to as the Java build path. If you're not running inside of an IDE, that often means making the jar file, the JUnit jar file, available via the class path environmental variable. Once you've got JUnit, how do you start to use it? Well, let's take a look at a simple little class, a Java class. We'll call it here the calculator test that represents a JUnit test. Say, for example, in this case we want to test one of our own components, a calculator class. Calculator test serves as a harness. That harness allows us to conduct several tests across the calculator methods. So in this case, calculator test with its test add method is annotated with add test to indicate that it is a JUnit test. Inside of that method, test add, we see an instance of the calculator created, and then the add method called on the calculator. We then see the final line of the code in test add as an assert equals method call. That assert equals is a JUnit API that allows us to test that the value that came back from calculator add is indeed the results we expect, in this case the value of 60. Now, a couple of things to note with regard to this little example that we see here first off. First off, even though we call this method test add, it wouldn't have to be. Older forms of JUnit required certain naming conventions with regard to unit test methods. That no longer is the case, but convention usually holds that we still add the word test to all JUnit test methods. Today, with JUnit 4, the only requirement is that we label with an annotation at test each of our test methods. Now, with regard to the assert methods, there are plenty of assert methods in the JUnit API, and we'll learn much more about those in a future upcoming chapter. We'll see that not only can we test for equals, but we can test for other things. For example, testing or asserting, if you will, that the results might be null. We'll also see that these are overloaded methods, meaning different signatures for many of these methods. In this case, the assert equals method takes 3 parameters. First, the expected value. Second, the result we actually got from, in this case, the component we're testing, which is calculator add. And lastly, what's called a delta. Is there some discrepancy we allowed for? For example, maybe we are looking for the result to be 60, but we'd allow the result to be 61 or 59, in which case our delta may be 1. More on the assert methods and more on this JUnit API coming up later on. So, some concepts we need to be aware of as we explore JUnit. First off, in this case, our calculator test class is what we call a test class. That class has to be public. Typically, the class name will end with test, but again, this is more convention than requirement today. Prior to JUnit 4, test classes actually had to end with test. And in some cases, we also found in older versions, again prior to JUnit 4, these test classes actually had to extend something. They had to extend a JUnit test case. In fact, today we actually refer to things like our calculator test as a test case. Again, no longer required, but often still held to today with regard to convention, that we call things a test case and end the class name with test. Methods inside of our test class are test methods, what we call unit test methods, and again they have to be annotated with @test. Unit test methods have the duty of examining the behavior of what we call a unit of work. We'll define more about what a unit of work means a little bit later on, but suffice it to say right now that it's all about a single method in one of our components in our application, in one of our classes in our application. And assert methods, again, check the results. By the way, should our test, our assertion, fail, in this case the value of calculator add did not come back with a value of 60, then we actually get an exception thrown at us. An assertion error provides an indication that the test actually failed. Now, how do we execute our test case with its test methods? In this case, again, our calculator test. To execute it, if you're running it from the command line, simply call Java with what's called the JUnit core runner, passing in as a parameter to the JUnit core the actual test case. In this case, again, our calculator test class. If you're not running from the command prompt, and most of us are not going to be, you're probably running things from inside of your IDE, in which case tools like Eclipse make running your unit tests even easier. Simply right-click on one of your test cases, again our calculator test in this example, and select Run as a JUnit test. What we'll see as a result of executing our test depends again on the environment that we're running in. If we're running it in a simple JVM, what we get back in the command prompt is little periods, or dots if you will, telling us how many test methods were actually executed and how long it took to run those. Any failure when run from the command prompt will be indicated with an E in place of that dot, or I should say in addition to that dot, in the actual results output, along with the actual stack trace, which will include again the assertion error. If running from inside of Eclipse, a nice little visual view built into Eclipse will show graphically the success or failure of our JUnit execution. Shown here in the top picture, we have JUnit with a green bar, indicating that all tests were run and run successfully. And the bottom a red bar, indicating at least one failure. In addition, the view provides an indication of how much time it took to run the tests, how many tests were run, and any kind of stack trace information, or if you will, failure trace information from the unit tests. Well, that's it. That's our first chapter from Express JUnit. I hope to see you in class real soon.